ये टॉपिक नंबर 5, फर्दर मोमेंटम। पहले आप मुझे बता दो व्हाट इज द फॉर्मूला फॉर मोमेंटम। मोमेंटम होता है कि इसको डिफाइन कैसे करते हैं?
mass into velocity.
It's the product of mass and velocity, exactly. ठीक है. So first, you should know how to explain the difference between elastic and inelastic collision. Make calculations based on conservation of linear momentum. Determine the energy changes in collisions. Derive and use the equation for kinetic energy and non-relativistic particle. और आपने ऑलरेडी लीनियर मोमेंटम के अंदर देखा है दैट मोमेंटम इज ऑलवेज कंजर्व्ड एज लॉन्ग एज कोई भी एक्सटर्नल फोर्स मजीद नहीं है सिस्टम में. बट ऑब्वियसली इफ देर इज एन एक्सटर्नल फोर्स दैट इज एक्टिंग इन द सिस्टम, या अगर हम न्यूटन्स थर्ड लॉ से देखें तो उसके अगेंस्ट फिर momentum can change before and after the collision. For example, if there's an external force, if there's an accident, if there's a force of friction, if there's a change in the road conditions, कोई opposing drag force एक नई enter हो चुकी है system में, then obviously kinetic energy can change as well, velocity can change as well. लेकिन अगर हम सिर्फ elastic collision की बात करें, in a collision between one pool ball and another, the first one will often stops completely and the second one then moves away. उसका क्या मतलब होता है कि पहली वाली pool ball ने सारा का सारा momentum has transferred into the second pool snooker ball and it is now moving forward. So that's what the principle of conservation of momentum tells us, that the velocity of the second ball must be identical to the initial velocity of the first. This means that the kinetic energy of the system of the two balls before and after must be the same as well, और हम उसको elastic collision कहते हैं. Exactly like the Newton's third law, that if an object A exerts a force on B, B will exert an equal and opposite force on object A. Action is equal to reaction. We got a perfectly elastic collision as well. उसमें बहुत little energy लॉस होगा, बल्कि सिर्फ ट्रांसफर हो जाएगा. अब कोलिजन कैन बी कॉज्ड बाय नॉन कॉन्टैक्ट फोर्सेस, जैसे कि अल्फा पार्टिकल स्कैटरिंग एक्सपेरिमेंट हम आगे कवर करेंगे इन योर न्यूक्लियर फिजिक्स एज वेल. वहाँ पे कैसे हुआ था. तो व्हाट डू यू थिंक इज मेंट बाय इनइलास्टिक कोलिजन देन, कैन यू टेल मी? इलास्टिक तो समझ आ गई, इनइलास्टिक कोलिजन्स में क्या होगा? In a crash, let's say between two bumper cars, the total momentum after the collision must be identical to the total momentum before the collision. However, if we calculate the total kinetic energy before and after, we find that the total is reduced by the collision. और अब kinetic energy सिर्फ kinetic energy में ही conserve नहीं रही, it has transferred to some other forms as well. जैसे कि heat energy during collision, या collision के दौरान जो आवाज़ आई बहुत ज़ोर की, that means some of it was converted to sound energy as well. और यहाँ पे total kinetic energy is not conserved. It has energy is conserved, kinetic energy is not conserved. इन दोनों चीज़ों में फ़र्क है. इलास्टिक कोलिजन कब होता है? जब वेलोसिटी भी सेम है बिफोर आफ्टर. तो अगर वेलोसिटी सेम है तो काइनेटिक एनर्जी बिफोर आफ्टर भी सेम है. यहाँ पे लॉ ऑफ कंजर्वेशन ऑफ एनर्जी अप्लाई हो रहा है, दैट यस द एनर्जी इज कंजर्व्ड बट काइनेटिक एनर्जी इज नॉट कंजर्व्ड. The kinetic energy has converted to other forms, so we'll call it inelastic collision. Inelastic collision का ये मतलब नहीं है कि energy is not conserved. Energy is conserved. Kinetic energy conserved नहीं है. For example, you can see that the velocity has changed. Over here the velocity has changed as well, and you can see now you'll have, if the velocity have changed, the total kinetic energy before and after is the same as well. यहाँ पे भी if you see, before आपके पास क्या थी दोनों की, और आफ्टर आपके पास दोनों की क्या है. बिफोर you had a total of 3900 joules and after you have 3000 joules. So yes, the kinetic energy has decreased. तो बाकी की, where is the rest of the 900 joules? Some of it might have been transferred. ये है ना, loss in kinetic energy was 900 joules, must be transferred in heat energy, must have been transferred in sound energy as well. So it can also be, investigated in school as well. Head-on collisions करते वक्त you can record the initial masses, the final masses, the momentum as well, and the change in velocity over here as well. Plus, we also know that the formula for calculating kinetic energy is half mv square, and the formula for momentum is p is equal to mv. We can then combine these two formulas to get the equation that gives us the kinetic energy in terms of momentum and mass. तो kinetic energy और मोमेंटम को आप किस तरह से लिख सकते हो? वी नो दैट मोमेंटम इज इक्वल टू मास इनटू वेलोसिटी. वेलोसिटी क्या हो जाएगा? मोमेंटम डिवाइडेड बाय मास. एंड इन प्लेस ऑफ हाफ एम वी स्क्वायर का वी स्क्वायर, कैन वी राइट देन पी ओवर एम स्क्वायर दैट वी हैव डिराइव्ड फ्रॉम द मोमेंटम फार्मूला. तो यहाँ पे यू विल हैव अ न्यू फार्मूला, यू कैन नोट इट डाउन विद यू एज वेल, दैट काइनेटिक एनर्जी इज इक्वल टू पी स्क्वायर ओवर 2m. This is the very first formula that you have to note down. This formula is particularly useful for calculations involving the kinetic energy of subatomic particles traveling at non-relativistic speeds that is much slower than the speed of light. In experiments to determine the nature of fundamental particles, physicists detected the movements of many unknown particles. Let's say एक large hadron collider, ये भी हम अपने topic 7 में देखेंगे, that how particle collisions have also lost some kinetic energy in light, heat, sound as well. वहाँ पे we'll be also discussing the conservation of momentum, because this conservation of momentum law is always going to help us calculate the unknown masses as well, mass 1, mass 2, mass 3, through different experiments. For example, the detector registers an elastic collision with one of its neutrons, और ये neutrons के through होती है. Large hadron colliders में एक neutron आएगा that is going to collide with the parent nuclei, और वो parent nuclei आगे daughter nuclei में तब्दील होगा, plus producing two more neutrons. And then these neutrons are then again going to collide with another parent particle ताकि वो भी आगे daughters produce करें. And this whole goes on. ये जो large hadron collider है, इधर एक chain reaction will keep on going, head on collision के साथ as well. And over there the speed changes as well. Before speed will be different, after speed will be different, and over there when you have all of the data, you can calculate any individual thing as well. Maybe you can calculate m1 separately as well, or m2 separately as well, depends on what the question is given to you. कौन सा mystery mass है that you have to find. It can be this a as well, it can be your mass b as well, and you will be given the velocities as well, same equation. If you know how to make this equation that we have already practiced in your as momentum as well, then trust me, this inelastic collision वाला सवाल will not be difficult for you as well. So over here we can find the mystery mass as well, and that mystery mass can then be used to find the unknown. और mystery masses को क्यों कह रहे हैं? Because over here the question is not just about finding the mass from the momentum question. The question over here is about finding the unknown particle. आपने यहाँ पे unknown particle find out करना है, and if you want to find out the unknown particle, that which was this mystery particle, for that mystery particle you have to calculate the mystery mass. तो आप उसको m1 बोल दो, ठीक है, या किसी और जो आपको बाकी मैसेज दिए हैं जैसे ये वाला था which we already know of a neutron, वो आपके पास m2 है. And once you have calculated this m1, then you can use a data booklet to tell that which particle was this actually. So elastic collision is a collision in which total kinetic energy is conserved, and an inelastic collision is a collision in which the total kinetic energy is not conserved. Clear?